Anyway, I'm going to tell you how to get an order of magnitude in software productivity for a certain class of applications. And it's going to be a real order of magnitude. So this is not an AI talk. There have been lots of AI talks up until now. Copilot is worth 50%-ish, as Daniel Jackson said, and it's going to get better over time. Stay tuned for an order of magnitude in a different dimension. Okay, how the context, everybody is moving everything possible to the cloud as quickly as possible. For cost reasons, resource elasticity, and so forth. So this is not new news, but you are all going to move to the cloud. The real issue is to fully leverage the cloud. All you have to do is look at the Amazon pricing system. You are highly encouraged to structure your application as a directed graph, a workflow of operations, passing state between these operations either through storage or as parameters to the next thing that's in line. And if you do this, you get charged for computing only when you're active, as opposed to if you bring up a server, you're charged all the time. So think AWS Lambda, think step functions. That is the cheap model if you want to move to the cloud. And we will assume that's what you want to do. So what kind of applications am I talking about? Well, let's look at the logic that's behind a universal data processing example, which is the workflow for the buy button when you click it in your web app. So what does the logic have to do? Well, you have to reserve inventory. John Werner wants to buy a widget. We got to see if we have one in stock. If that's okay, then we want to check John Werner's credit to make sure we want to do business with him. If that's okay, then we want to activate payment and take his money. And once we do that and it's okay, then we want to schedule fulfillment, i.e. ship him the widget. So this is a typical workflow in a wide variety of business data processing applications. The problem is stuff can go wrong. Lots of stuff can go wrong. So the first guarantee that you would like for such a workflow is to get what's called in the business community once and only once. You don't want to pay for anything twice. You don't want to ship anything twice. One regional bank estimates that 40% of their code base, all it does is implement once and only once. Now you say, how can this be a big problem? The answer is there are crashes, there are restarts, there are disasters. You resume the workflow. You've got to make sure this guarantee is true. Second thing is we get all the way down to the bottom of John Werner's widget, and we see he's given us a bad address. So if he's given us a bad address, we've got to unwind everything, which means we've got to give back his payment. We've got to release the inventory. And that gets kind of tricky because that isn't necessarily just physically back out what we did. Often, the compensating transaction for decrementing inventory is incrementing it. So we'd like that guarantee out of a platform. Third thing is the workflow finishes in spite of whatever. Whenever there's a crash, we want to finish the workflow. Harder yet, if there's a ransomware attack, we want to finish the workflow. So these are desirable workflow guarantees that you would like out of whoever is running your application. If you get these guarantees, then the really nice thing is you get to write Daniel Jackson's operation logic, and the platform handles everything else. Everything else means orchestrating the workflow, which is scheduling the next thing in line when its inputs are available, careful bookkeeping on errors to support once and only once. You've got to support sagas so you can back everything out. And if you want to deal with ransomware attacks, so a ransomware attack happened 14 minutes ago, you've got to back up everything 15 minutes and then resume processing, single-stepping around the attack. So that takes time travel of everything. You've got to be able to go backwards and then forward. And then, of course, if you're writing anything at scale, you've got to do load balancing across multiple instances, and you've got to increase and decrease the number of instances when there are too few or too many. If you do this, this is worth an order of magnitude in software productivity. It's all this dreck, which nobody wants to do, but you have to do it anyway. So according to early DBOS programmers, you get done, they got, a quote was, we got done in 2 days what it took 2 months in AWS. Okay, so this is worth an order of magnitude, and all you have to do is run a platform that handles all this stuff. So other goodies, well, you'd like a time travel debugger, because debugging parallel code is really hard. If you can back up everything, then you can back up a single application, no big deal. Performance is a big issue. So to make stuff go fast, you want to co-locate orchestration, the operations you're running, and the DBMS. So you just do that. It's not all that difficult. And you want something to be cheap, i.e. much cheaper than AWS Lambda. Okay, so what else do you want? Well, you'd like better security. Security is a big issue typically after the fact, after the horse has been stolen from the barn. So DBOS has a much smaller attack surface than whatever you're using, because it doesn't involve Linux and it doesn't involve Kubernetes. So much simpler world. And all events that happen are recorded for as long as you want to keep them in a data warehouse, so you can do selective or full recovery to any point in the past. Okay, so what do you get? You get an order of magnitude productivity improvement. This is in a different dimension than what Daniel Jackson was talking about. This is not intended to make your application easier. So you write just the code logic. This is all this other stuff that you'd like not to have to do. And together with lower cost and better performance and better security. So dbos.dev is a commercial enterprise of an MIT and Stanford prototype that we worked on for 3 years. Go check it out and see what you think. I'm done. On time.